Today we're going to look at section 6.6, and we're going to spend 2 days on this. This deals with vectors. So today you're going to learn about what a vector is and how to manipulate vectors, and then tomorrow we'll start some word problems. Vectors are real important for those of you who end up taking physics or go into engineering of any sort. Okay? So a vector has a magnitude and a direction. Alright, and let's define magnitude is the force, the speed, or the length. And direction is obviously what it means. What way is it heading? Okay. Which way is it heading? So vectors are going to look like rays. P is called the terminal point. I'm sorry, P is the initial point, Q is the terminal point. Okay? And then the symbol, it's like a double absolute value sign with PQ in the middle, is the distance from P to Q. In other words, its magnitude. Alright, a couple more little things and then we can get into work. This is the symbol for vector. So you'll notice that it is this vector V, and it just has like a half little thing on top. So instead of it being like a ray, it's just this one. Vectors are equal if they have the same magnitude and direction. Example 1. Show the vectors are equal. And I'm going to go ahead and grab my textbook, and we're going to be working off the vectors on page 651. So if you prefer to look at your own book as opposed to try to read off mine, that's fine too. Alright, so 651. Maybe not. Alright, sorry guys, it's page 681. Alright, so we're going to look at vector U and vector V. And they tell us the initial point and the terminal point, initial point and the terminal point. So what you're going to do is go ahead and think about how would you find the magnitude? How do you find the length of this vector? Well, I believe the distance formula would be a great way to do it. So let's go back in time and see if you remember the distance formula. Let me see if I can grab my paper, and I'm going to go ahead and unzoom just a little bit. Whoops, that's the opposite of what I wanted to do. Alright, so distance formula is the square root of the difference in the x values squared and the distance in the y values squared. Alright, so let's go ahead and plug in. so if I look at vector u first, so his x values are negative 3 and 0, so negative 3 minus 0 squared plus negative 3 and 3. So I get the square root of negative 3 squared plus negative 6 squared so I get the square root of 9 plus 36, which is the square root of 45. And then let's clean this up. Do you agree that that's really, what, 3 square roots of 5? Alright. So now let's look at vector v. So vector v is 0, 0, and 3, 6. So again, let's go ahead and subtract our x's. So I'm going to write down the formula again, just in case you need it. X minus x squared plus y minus y squared. And let me go ahead and zoom in since we don't need the book anymore. Alright, so it's the square root of, let's see, his x values we said were 0 and 3. His y values were 0 and 6. So I have negative 3 quantity squared plus negative 6 quantity squared. Remember, negative 3 squared is 9. Negative 6 squared is 16. So I get the square root of 20. Sorry, how about 36? Guys, I'm still battling this touch of this whatever I had yesterday. So I don't seem to be quite as on point as I normally am. Okay? So we know that they have the same magnitude. The question is now, do they have the same direction? So to find direction, we're going to do slope. Now remember, there's two ways you can find slope. You can count rise over run, or you can do y minus y over x minus x. Okay, so both work. You decide whether you'd like to count on a graph or whether you'd like to plug into a formula. For me, I think let's count on the graph since they're already graphed. Alright, so I'm going to look at the slope of u and the slope of v. Alright, so let's go back to our picture and count blocks. So slope, rise over run. 1, 2, 3, 4, 5, 6, 1, 2, 3. So the slope of u is positive 6 over 3, which is 2. Alright, let's count this other guy. 1, 2, 3, 4, 5, a rise of 6, a run of 3. Therefore, the vectors are equal. Alrighty? So that's the first thing we can do with vectors. Now, let's get a little bit more vocabulary too. If this is vector v, I can double him, so I can make him twice as long. Excuse me. I can make him half his size. I can make him go the opposite direction by changing him. Alright, so I can double him, I can shrink him. I don't have to just double him. I could triple him, I could make him 5 times, whatever. So I can multiply, I can make him smaller, I can flip him around. Okay? If k is greater than 0, then it goes the same direction. And if k is less than 0, the vectors have the opposite. Let's go back and fix my grammar in the first sentence. So if k is greater than 0, the vectors have the same direction. If k is less than 0, the vectors have the opposite direction. Alright, last thing we're going to talk about as far as vocab goes is what the resultant vector looks like. Now what vectors do is they always hook head to tail. So this is vector u. Vector v is going to hook right into where his head is and go this way. So if I want to add these vectors together, what I get is this diagonal here. Okay, so this is vector u, this is vector v. The sum of vector u and v is this diagonal line. Now we're going to put this in a rectangular coordinate. And I'm actually going to start a new page. So we need to put this in the rectangle coordinate. So we let I equal the horizontal. We're going to let J equal the vertical. So in other words, this will now be I, this will be J. So now what you'll see is that we have some distance this way, which we'll call AI, right? A is any number, so this could be 3, this could be 10, this could be 50, plus BJ. So again, any value of, right, this could be 4y, 5j, 10j, and what we get is our resultant vector will be AI plus bj. So if I ever want to find the magnitude of that vector, I'm just going to take the square root of a squared plus b squared. If you think about it, this is really just a right triangle, right? And to find the hypotenuse, I can just square those two sides. It keeps me from having to do the distance formula. Alright, so let's practice a couple of that skill. Example 2. Sketch V equal to 3I minus 3J and find its magnitude. Okay, so 3I minus 3J. So 3I is positive, so I'm going to go ahead and go positive, so 3 to the right. There's 3I. Negative 3j. So I'm going to go down negative 3j. And my resultant vector would be this one. Okay, so maybe we should highlight that resultant vector so you know what it was that I sketched. Now what I want to do is I want to find that magnitude. So to find the magnitude, I come over here and I say, well, hey, it's really the Pythagorean theorem, correct? So the magnitude of V would be the square root of 3 squared plus negative 3 squared. So 9 plus 9 is the square root of 18. And that, remember, if you come over here and break it down, if you remember how to do that, we said factors of 18 are 2 and 9, 3 and 3, so I get 3 square roots of 2. Alright. Next thing we're going to do is learn how to write vectors. So there's a lot we're learning in this chapter. Luckily, none of it is too difficult. Alright, so to write vector v, if I was given the 2 points, I'm going to take x2 minus x1, I, plus y2 minus y1, j. Now, remember when you guys did slopes, it didn't matter whether you did the 1s or the 2s first, but for vectors, the second point has to come first. Okay, so let's write that out. The second point, which is the terminal point, must come first. If not, you get the wrong sign for your vector. Okay, so let's practice that. Example 3. Let v be the vector from P1, negative 1, 3, to P2, 2, 7. So my vector starts here. This is my terminal point. So I'm going to go ahead and highlight my terminal point. So this is the point that I have to use first. So of course, in highlighting him, I messed up his look there. Alright, so the formula I just gave you was x2 minus x1 I plus y2 minus y1 j. That's going to be defined as vector v. Alrighty? So I write down the little skeleton formula. I start with his x value, which is 2. Now I go to his x value, which is negative 1. Go back to P. Tell me what his y value is, or P2. Go back to this point, your terminal point. His P2 is 7. And the beginning point was 3. And now we can just clean it up. 2 minus a negative 1 is 3i plus 4j, and that's vector v. Now, we can do lots of things with vectors. We can add vectors, we can subtract vectors, we can do multiply vectors. If v is equal to 7i plus 3j, and w is equal to 4i minus 5j, the first thing I want you to do is find v plus w. Then I'm going to ask you to find v minus w. Okay, this is going to be exactly like what you expect. Let's write down vector v. So vector v is this, plus vector w. Vector w is 4i minus 5j, and now we're really combining our like terms. So 7i and 4i make 11i, and 3j minus 5j is negative 2j. Let's try subtraction. Alright, so I fill in vector v. It's 7i plus 3j. I fill in vector w. 4i minus 5j. Now be careful. What do we need to do with this negative? That negative, remember, is going to get distributed. So I really have 7i plus 3j minus 4i plus 5j. Now I can go ahead and combine my like terms. 7i and minus 4i is 3i. 3j plus 5j is 8j. And that's how you add or subtract. Alrighty. Tomorrow we'll pick up in class how to multiply and then how to do just one more thing with vectors. But easy stuff tomorrow. You guys have a great evening, and I'll see you in the morning.